All right, so we're continuing on with being able to simplify expressions using our exponent rules. And we're going to start with focusing on a exponent that is a zero, so a base raised to a zero power. And so just to give you some background with this, is that if you think about what we have here, 2 to the 0 power, if you look at the pattern, 2 to the first power would be 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16. If we work in reverse here, what we're actually doing is looking at this pattern is taking 16 and dividing it by 2, excuse me, to get 8, and then taking 8 and dividing it by 2 to get 4, and then 4 dividing it by 2 to get 2. So if we wanted to know what 2 to the 0 power is, if we take 2 and divide it by 2, then we could see our answer is going to be 1. Now, just like we've done with our other exponent rules, we don't want to do that every single time. We just need to know that if we have a base raised to the 0 power, that our answer is 1. And that is true whether our base is a constant like it was here with 2, or if our base is a variable like it is here with x. Those both still simplify to 1. Now, we do have to be careful as to what is the base. So if we look at this 3x to the 0 power, the 3 is not being raised to the 0 power. Only the x is being raised to the 0 power. So that 3 is going to remain times, here's where that x to the 0 power, that is our 1. So that's going to be 3 times 1, and then our answer will be 3. So we have to be careful. A lot of times students will get into the habit of, if they see something raised to the 0 power, that they automatically just want to put in a 1. But we have to make sure that we identify what is the base and what else is going on in the problem. Okay? Now let's start to look at some of our more multi-step ones. That's the purpose of this video, simplifying expressions that have exponents of zeros, and then looking at more multi-step problems. And this is our first one that is a multi-step problem here. And so I'm going to have to take first and address this numerator. And so this numerator tells me to take 2 squared and then x to the third squared. And so when I do that, I'll have 2 squared is 4. And then a power to a power, I multiply, so that is x to the 6th. Now, in the denominator, I can't simplify x to the 4th, so I'm just going to bring it along with me. But then here in my last step, I'm going to simplify from numerator to denominator. 4 divided by 1 is 4. And then x to the 6th divided by x to the 4th, there's going to be 2 x's left in the numerator. So everything in the denominator left is a 1. We don't have to write a denominator of 1 just like we do with any other. We can just leave it as 4x squared. So if we look at this problem, this is actually a 2-step problem. So let me look at how I would approach this first. When I look here, this tells me I am going to need to multiply everything there, or excuse me, I'm going to have to raise everything there to the 2nd power. And then when I'm finished, I'm going to have to take 2x and multiply it by whatever this is when I square it, when I multiply it to the 2nd power. So my first step I'm going to take, and I'm going to go off to the side here and say, well, this would be 3 to the 2nd and x to the second to the second. And so that 3 squared, 3 times 3 is 9, and a power to a power, x to the 4th. And so I'm going to write that right in here. That was my first step. And now my second step is I need to multiply. So I'm multiplying my coefficients first. 2 times 9 is 18. And then I'm multiplying my like terms next. I've got an x, this is to the first power, and an x to the 4th power, which is x to the 5th. Now I know that I'm finished because I have a constant and a variable raised to an exponent, and that's as far as I can go. And so my answer is 18x to the 5th. So if I look at my next problem, this is actually a 3-step problem. I'm going to have to take this first parenthesis here, and I'm going to have to raise everything in there to the second power. And then I'm going to write that result right here. I'm going to have to take this parenthesis, and I'm going to have to raise everything to the 3rd power. And I'm going to write this result here. So those are my first 2 steps. My last step will come when I multiply these 2 parentheses together. Okay, so let me go off to the side here. Now this is where it depends on how comfortable you are with these exponent rules. Maybe you always go off to the side and work the problem out. Maybe you're okay at doing them in your head. At this point, it's really what you're comfortable with. So I'm going to take -2, I'm going to raise it to the 2nd power, and x to the 1st to the 2nd power. So -2 squared will give me 4, and then 1 times 2 will give me x to the 2nd. So I'm going to write this in here. That's what the result of squaring everything in that parenthesis is. Then I'm going to come over here, and this is going to be 3xy to the 3rd power. And I'm going to cube everything in here. So I'm going to have 3 to the 3rd and x to the 1st to the 3rd power and y to the 1st to the 3rd power. And so I'm going to have 3 times 3 times 3 is going to give me 27. 1 times 3 is going to give me x to the 3rd. 1 times 3 is going to give me y to the 3rd. And so I'm going to write this result in here, 27 x to the 3rd, y to the 3rd. So those are my first 2 steps. My first step is in red. My second step is in green. And now I'm ready, or is in blue. And now my final step is going to be in green here when I go and multiply these 2 things together. Okay, so the first thing is I'm multiplying my constants. So I'm taking 4 times 27. And then I have x to the 2nd and x to the 3rd. So if you need to visualize, there's 2 x's here, there's 3 here. That would be x to the 5th. And then I can't forget that there's y to the 3rd. Even though there's not a y over here, that y to the 3rd needs to show up in our answer. So here is our answer right here.